Hello, everyone, and welcome back to another concept session for Math 170. My name is Nick, and I work at the ASU Tutoring Centers, and today we're going to be talking about the law of cosines. So before we get started with this problem, let's just go ahead and talk about what law of cosines states. So given a triangle, okay, with angles capital A, capital B, and capital C, and corresponding sides, lowercase a, lowercase c, and lowercase b. Note the lowercase sides do have to be opposite of the capital letter angle. So lowercase a has to be the opposite side of capital A. Lowercase b has to be the opposite side of angle capital B, and so on and so forth, right, with c. Basically, given this triangle, we can actually find, in this case, what this a is equal to by doing a squared equals b squared plus c squared minus 2bc cosine of capital A. So essentially what we're doing is capital A, finding the cosine of that, multiplying it by the side of b and the side of c and 2, and then finding b squared plus c squared, and then subtracting the 2, and that gets us 8 squared. All right, so let's go ahead and tackle this problem and set this up. So for any kinds of problems like these, what I usually like to do is kind of draw just like a rough coordinate plane. But instead of having like the x-axis and y-axis, what I'm going to do is label them as our directions. So we have south, east, north, and then west. Now, let's go ahead and read this problem. So 2 ships leave a harbor at 1 p.m. Ship A travels at a bearing of south 18 degrees west at 14 miles per hour, and ship B travels on a bearing of north 80 degrees east at 11 miles per hour. How far will the ships be at 5 p.m.? So first, let's just go ahead and kind of draw it out. So for ship A, they're saying bearing of south 18 degrees west. Now, essentially what that means is that they're going south. They're basically going southwest, right? So think of the south as like, okay, we're going to travel down the south axis here. And then the 18 degrees west is basically going to look like something like this then. Okay. So basically what they're saying is this angle here is 18 degrees. Okay. And then we'll do the same thing for B. So that's A, right? And then for B, they're saying on a bearing of north 80 degrees east. So we're going to go up towards north, and then it says 80 degrees east, which is pretty significant, right? So it's going to look like something like that. And this is going to be our 80-degree angle here. So this is A. Or sorry, this is B. There we go. And if you notice, what we can do is connect these 2 points, and it forms a triangle, right? What we can actually use with using law of cosines, right? So we don't know what the length of this side is, right? We don't know what this inner angle is, and we don't yet know what the sides are, but we can solve for a lot of this. So A is actually going to be our answer, right? So how far will the ships be at 5 p.m.? This A is the distance between the 2 ships, right? So first off, what we need to do is find and figure out how far have these 2 ships gone already, right? So the difference between 1 p.m. and 5 p.m. is 4 hours, right? So what we can do is essentially just calculate the distance by multiplying the miles per hour by the total hours. So for ship A, they traveled at 14 miles per hour. And we can multiply that by 4. And that tells us that they've traveled 56 miles so far. Okay. And then with B, we multiply 11 miles per hour by 4 hours, and that gets us 44 miles. So that's what these the lengths of these two sides of the triangle is. So we have 44 here and 56 here. Now what we need to do is calculate this inside angle, right? That's really the last thing we need to do here. So if we're going to break this down, and actually I think it would help if I just kind of rewrote the triangle over here just to make it a little bit easier. So we know that, I'm going to clean that up actually. There we go, a little bit better. So we know that this degree over here is 80 degrees, right? So what we really need to do here, and the easiest way to kind of do this is to really just break down the angle here. So we're trying to find this angle here. Okay, so it's that guy. And what we need to do is just kind of break it down into chunks. So we know that this angle is at least 90 degrees, right? So, and we already know that the little chunk past the 90-degree mark here is 18 degrees. So we know that from the east axis all the way to where ship A is, that angle is 90 plus 18, right? We just need to figure out this extra part above east. And we know that there's 90 degrees, right, and a right angle here. And we know that this from the north axis all the way to where B is 80 degrees, right? So if we subtract 80 from 90 degrees, we should find that remainder angle here that we can add to it to give us our total angle. Now, when we do that, so that would basically be saying 18 degrees plus the 90 plus the 10. And then when you add all of that up, it gets you 118. So that's what this angle is here. Okay. Now what we can do is now just plug everything back into our law of cosines equation. So we're trying to find A, right? So we're going to keep that A squared. We know what our B is, right? So our B is 44 squared plus our C squared, which is 56 squared, minus 2 in parentheses our 44 times our 56, and then multiplying that with our cosine. Oh, apparently I don't know how to spell cosine. Cosine of 118. Then when you plug all of that in, you get A squared equals 7385.56. And then lastly, what we need to do is square root both sides. That gets rid of the squared, and then we get A equals 85.9 miles. Again, definitely make sure that you include units here, right? So they want to know how far apart the ships are, 85.9 miles. So that's basically law of cosines in a nutshell. If you have any other additional questions, go ahead and check out tutoring.asu.edu for more information on all of the free resources available to you from being an ASU student. If you enjoyed this concept session and want to check out more just like it, go ahead and click on that other link on your screen, and that'll direct you to a full list of all the other concept videos we've done for not only this class, but also for a multitude of other ASU classes, so definitely check it out. But other than that, I hope you have a great rest of your day, and good luck in your course.